Hello. So now we are in the module 3 of this course, that basics of non-parametric test with application by R. In this module, the first lecture comprises on general discussion on two sample test, and at the end of the first lecture I am going to give you some flavor on Mann Whitney test. To be more meticulous, let me say that in two sample testing problems, I am going to cover two sample location problems, two sample scale problems, as well as two sample location cum scale problem. So let us start the journey. What is two sample testing problem? By this name, it is clear that two sample testing problem means there should exist two samples. But you have to remember these two samples must be independent to each other. It is not like the paired sample case. In paired sample, even if we have two types of sample, but those samples are related to each other, like before and after the situation. But in two sample, these two samples are coming independently from two different populations. So let us call these two independent population as x and y with cumulative distribution function fx and fy respectively. So first thing which you need to remember, that these two stack of sample observations are coming from two different population, independent population. So a random sample of size m, x1, x2 till xm drawn from the x population, and another random sample of size n, y1, y2, yn is drawn from the y population. Now what will be our hypothesis of interest? Our hypothesis of interest is whether these two populations are identical, whether these two populations are same or not. And what will be our alternative? Our alternative is these two populations are not same. Now when we are saying that these two populations are not same, we have to mention that, well, I understand that these two distribution functions or these two populations are not same, but they are different in which ground? They might be different in the ground of the location parameter, they might be different for the ground of the scale parameter, they might be different for both of location and the scale parameter. So basically two sample testing problems in fact deals with these three categories of testing, where first one, the populations are different by their location parameter. Second one, populations are different by their scale parameter. And the third one, populations are different by their scale and location both parameter. Now in this lecture, we are starting the most usual concept that populations are different by their location parameter, and that's why it is called location testing problems. Now suppose you have two random variables x and y, and we will say that y is shifted right to the x if x and y are sharing a shift of the location by theta. So mathematically, how to interpret this concept? Just have a check that fyx is equal to probability y less than equal to small x. Small x is the value taken by the random variable capital Y, and that is equal to probability capital X less than equal to small x minus theta. The point will be clearer if you just look at the picture below. You will see this is fyx and you will see this is fx. Now fix one point x and if you go backward by theta unit from this small x, from this particular point, then x minus theta, this point will be achieved. And what is the height of x minus theta? That is f capital X, x minus theta. Okay. So, this height capital Fx small x minus theta is same as the height capital Fy small x. So, the point at the y distribution is same as the point in the x distribution if you are moving backward by theta unit, and that theta, that distance, that difference is the location parameter, and we will say that it is location shifted distribution. X has a location shifted distribution of y, or y has a location shifted distribution of x. X distribution and y distributions are same when these two distribution function will be superimposed to each other. When do they superimpose? When your theta is equal to 0, when there is no such location gap. Y distribution is shifted to the right. Now just have a look over this, shifted to the right to x if theta greater than 0, and you can see that the y curve is more right as compared with the x curve. Clear? Y curve is more right as compared with the curve or distribution curve by x. Similarly, we will say y is shifted to the left if theta less than 0. Then you can see Fy is lagging behind Fx x minus theta. Theta is negative. That means when I am writing x minus theta, essentially what it is meaning, x minus minus of theta, because theta is negative. So, essentially x is theta unit ahead of y, and y is lagging behind x. Now, these two situations, statistically speaking, these two situations have two different names. Y is stochastically larger than x. We say y greater stx, y stochastically larger than x if x distribution is lagging behind y, and y is stochastically smaller than x if y distribution is lagging behind x. So, be very cautious regarding the inequality. Clear? Scale model assumes that x and y populations are same except for a scale parameter Fyx, which is equal to probability y less than equal to small x, and this is equal to probability x less than equal to theta x, and that is equal to Fx theta into x. So, you can see earlier it was x minus theta, now we are multiplying theta into x. So, theta here is a scale parameter. A more general model is location scale model, which states x minus mu x by theta and y minus mu y are identically distributed. Here mu x and mu y, these two are the location parameter, while theta is the scale parameter. In general two sample testing problem, testing strategy is based on sample pattern of combined arrangement of x's and y's. This arrangement is done in terms of the observations arranged by respective magnitude in ascending order. Suppose you have two samples, one is from x and another is from y. So, in x you have 5 observation 5, 8, 2, 0, 3, and y you have 6 observation 7, 1, 4, 2, 9, 6. Combined ordered arrangement you have to make it. That means you have to mix both x and y and let all the observations be arranged in their increasing order. So, in increasing order you will have 0, 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, and at the bottom just see I have written from which population this sample is coming. So 0, it is a member of the X population. That's why I have written small x. 1, it is coming from the second population, means from Y population. That's why we have written as Y. So basically, after everything is done, you will have one sequence of X and Y, X and Y. Now, the two sample location problem is constructed on this pattern of X and Y. The basics, the strategy adapted in two sample location problem is deeply connected with this pattern of mixing of X and Y in a combined sample. So, the most widely used two sample location problem is done by Mann Whitney test. In Mann Whitney test, what you are trying to test? You are trying to test that two distribution Fy and Fx, they are different by the shift of location. So here you can see that Fyx is equal to Fx small x minus theta. Clear? That means these two distributions will be identical if these location parameter, this theta parameter, it is a location parameter, theta is 0. Clear? And the y is stochastically larger than x. So if your alternative hypothesis is this, that y is larger than x, y is stochastically larger than x, that means most of the y observations are bigger than the x observation. That's what probabilistically called stochastically larger. Y is stochastically larger than x. This is in other way round can be made as the alternative hypothesis that theta greater than 0. So the primary assumptions, x and y populations are continuous. As we know, for any kind of non-parametric testing theory, we have to assume that x and y are continuous distribution, and you have the sample observations like x1, x2, xm and y1, y2, yn. The Mann Whitney test is the number of times a y precedes an x in the combined ordered arrangement. Okay. So when your alternative hypothesis is y is stochastically larger than x, then what you need to see, you need to check how many y's are coming before x, y precedes an x, how many y's are smaller than x, even though we are testing y stochastically larger than x. Clear? Stochastically larger than x means mostly all y's are expected to be bigger than x. Now, Mann Whitney test statistic, what we are checking? We are checking just the reverse, that how many y's are coming before x. Okay. So, define Dij, which is an indicator variable 1, 0 if yj less than xi and if yj greater than xi. How many xi's are there? M xi's. How many yj's are there? N yj's. So, how many comparison one has to make? Total m into n comparison you have to make. Therefore, you will have a total of mn Dij's value. Mann Whitney statistic is defined as sum of all Dij's. So, double summation Dij's means what is the number of the total of Dij's, that is the U statistic. Now, if your alternative hypothesis is y stochastically larger than x, that means the distribution function will be in reverse order. Look at the inequality. Stochastically larger than x, that means for smaller value of x, probability will be higher, and for larger value of y, the probability will be higher. So, that is Fyx less than equal to Fxx, the reverse inequality, even though I am saying y is stochastically larger. If you want to make it clearer, just get back to the picture which I have given in the second slide, you will understand. Now, under alternative hypothesis, what you can expect? You can expect that u is small because we are checking how many y's are lagging behind x. So, define probability y less than x is equal to p. So, under fyx is equal to fxx, p is equal to 0.5. So, under the null hypothesis, when two distributions are same, this probability is 0.5. Now, what will be the alternative hypothesis? Alternative hypothesis will be p less than 0.5 clearly. So, expected value of u is expectation of dij. So, that will be mn into p. Expectation dij is a Bernoullian variable, and expectation of any Bernoullian variable is p. So, mn into p, that much pair you need to check. And under the null hypothesis, expectation of u is equal to mn divided by 2, because under null hypothesis what you have seen, that p is equal to half. So, under H naught, the probability distribution of u is symmetric about its mean mn by 2. Remember, I told you that for linear rank statistic, mostly if the rank statistics satisfy one conditions, then that will be symmetric, and that condition was mentioned in our lecture of linear rank statistics. So, u satisfies that condition, that conditions related to the score variable. That's why u also is symmetry. For particular arrangement z of the m x's and n y letters, says from smallest to largest, there exists a conjugate arrangement z prime where same numbers written from largest to smallest. What actually I need to say by this statement, that if you arrange mx and ny from say smallest to largest, there will exist one more complementary arrangement. Let me name it as z prime, where the same number can be written from largest to smallest. So, essentially for every arrangement there exists one complementary, or statistically speaking, a conjugate arrangement. Clear? So, for that conjugate arrangement, we may define one more variable, one more test statistic, that is called u prime, and u prime is double summation 1 minus dij. Suppose you have one arrangement like x x x, y x, y y, y y. So, how many x's are there? Value of m is 4. How many y's are there? Value of y's are 5. Clear? Then how many y precedes x? So, you can see only this y precedes x, means how many y's are coming before x. Clear? So, only this pair y less than x, so u is equal to 1. On the contrary, for u is equal to 1, what will be your conjugate value? That how many x precedes y? How many x coming before y? Now, just calculate out first x, stick to the first x. So, x is less than y, so assign 1. This x is less than the second y, assign another 1. This x is less than third y, fourth y and fifth y. So, for the first x, the value is 5. Clear? For the second x, the value again is 5. So, total 5 plus 5. For the third x, the value is again 5. Third x is less than the first y, third x is less than the second y, third x is less than the third y, fourth y and fifth y. So, 5 plus 5 plus 5. Now, coming down to the fourth x. So, fourth x is bigger than the first y. So, the assignment will be 0. But fourth x, that means this x is less than second y, less than third y, less than fourth y and less than fifth y. So for the fourth x, the score will be 4. So altogether, what is the total score? 5 plus 5 plus 5 plus 4. So altogether, this is 19. And that's why this u prime is 19. Clear? So the rejection rule based on u and u prime, if you want to test y is stochastically larger than x, which in turn implies fyx less than fxx. Once again, a quick reminder that when I am saying y is stochastically larger than x, the distribution function maintains the reverse inequality, right? And we can see the value of u will be smaller. So that will be a left tail test, u less than equal to C alpha. Similarly, when you want to test x is stochastically larger than y, the u prime will be smaller as compared with u. And what will be the rejection criteria? U prime less than equal to C alpha. Okay. So these two C alphas we can look from the table. And when it is a two-sided test, that fyx not equal to fx, that means few x can be larger than y and few y can be larger than x, then your rejection will be coming from both of the sides, u less than equal to C alpha by 2 or u r prime, that is the conjugate, u prime less than equal to C alpha by 2. So the same critical point. Clear? Generally, the computational process is find out u star, which is minimum of u and u prime and which is less than C alpha by 2. So stick to the minimum of u and u prime and figure out whether that u prime is less than equal to C alpha by 2. And for n1, n2, that means for m and n, m means for the first sample size, n means for the second sample size. So n1 and n2 are synonymous with m and n. So for these values n1 and n2 and for alpha, one can see all the critical points right from Mann Whitney U table. Okay. Moreover, in large sample, if minimum n1, n2 tends to infinity, minimum of n1 and n2, minimum of m and n tends to infinity, one can always have the freehold to convert u to the very usual Z test, to the very usual normal test. Clear? So this is the Mann Whitney table, and you can see that at the top n1 is there, at the bottom, along the rows n2s are there, and alpha, for two alpha values are here, 0.05 and 0.01. Suppose you are thinking about alpha is equal to 0.05 and your second sample size is 4 and your first sample size is 5, then the C alpha, the critical value, comes up as 2. Can you see that the blue circled numeric, that is your critical value. Similarly, you can look for any value, but remember this is a one-tail picture, one-tail scenario. In case you have two-tail picture, then you have to go for the table valid for two-tailed testing. Let us have quick examples. First we are going to solve this example manually and then we will switch to the R programming. The following data shows the age at the diagnosis of type 2 diabetes in young adults. Test if the age of diagnosis in males is higher than that of females. So higher than means if you consider the age of diagnosis of diabetes in male is as X variable and Y for the female variable, then when I am saying X is higher than that of females, that means X is stochastically larger than Y. Okay. So that's what you can see, X greater than Y means X stochastically larger. In terms of the distribution function, that will be Fx less than Fy. I told you the inequality will be reversed. So if X is stochastically larger than Y, that means we have to consider how many X are falling behind Y, just the opposite. We can expect more X will be larger than the Y figures, but we will calculate, or we will fix our decision criteria on the basis of the count on how many X are lagging behind Y. So that's why U is double summation Dij, and how many comparison you need to make? M is 5, N is 4, M is the first sample size, or N1 is 5, N2 is 4. So altogether 20 comparison you need to make. Okay. Now you have to arrange all X and Y observations in their increasing order, and you will see that by the side of every observation I have written from which population it is coming. So 11 is the smallest observation, and 11 is coming from Y, and because of its rank I have written it as Y1, that is, it is the first observation in Y sample. So finally you will have an arrangement comprising all X and Y figures. So let us see the arrangement: Y1, Y2, X1, Y3, these and this. Now if I ask you that how many X falling behind Y, how many X are smaller than Y? Now just count it out. Stick to this X, X1. X1 is less than Y3, X1 is less than Y4. Is there any other Y for which X1 is smaller? No. So this will be Dij plus 1 and plus 1. Now stick to the second observation of X, X2. X2 is less than Y4. Is there any other Y for which X2 is smaller? No. So X2 less than Y4, Dij value is plus 1. So altogether you calculated is 3. Similarly, if you are a little more interested, you can go for U prime. That means how many X bigger than Y, or how many Y are coming before X, and you will figure out that value is 17. Okay, let us check Y1. Y1 is smaller than X1, Y1 is smaller than X2, Y1 is smaller than X3. So you can just make the count and you will have the total score as 17. So you calculated is 3. Look at the table for the tabular value. If N1 is 5 and N2 is 4, U tabular at 5% level of significance comes up as 2. So we reject the null hypothesis if U calculated less than U tabular. But what we can see, 3 greater than 2, so we fail to reject H0. Age of diagnosis for male and female are same. Similarly, one more example I am posing in front of you. But you have to be very clear what your alternative hypothesis is, because you have seen that on the basis of the alternative hypothesis, your rejection region can be decided. So this is an example over new hybrid seed produces a bushier flowery plant, and for the following data on each shrub's sampling girth under current variety and hybrid variety was collected. Examine if the data indicate that the new hybrid produces a different shrub than the current variety. So if you consider current variety girth as X and Y is the hybrid variety girth, then what we need to test, Fx is equal to Fy against Fx not equal to Fy. Why not equal to? Because look at the final sentence of this question, that hybrid produces different shrub. It doesn't say superior or improved shrub in terms of the girth. It says, is it different from the previous one? So that's why we are taking as inequality, not equal to, as our alternative hypothesis. So if it is a not equal to as your alternative hypothesis, you have to figure out both u and u prime. So the first, arrange x observations and y observation in increasing order in the combined sample. Find out u, that means how many x lagging behind y. Find out u prime, that means how many y lagging behind x. Because it is a two-sided test, figure out u star, which is minimum of u and u prime, that comes as 8. Now look at the table for two-tailed test, and u tabular is 3. Since u star greater than u tabular, we fail to reject the null hypothesis. The new hybrid seed cannot produce the different shrubs. So that's what your conclusion should be. Okay. So next class we will learn how to use Mann Whitney test by R programming. In R programming, the decision criteria is a little different. We will learn in our next lecture. Thank you.